have to crisscross like that?
If you're given the name.
Okay.
Now, if you're not given the name and I give you the formula, you could just go and do what Bo's doing right now,
Okay.
the dissociation part. Now, be careful too. We had problems where we said concentration of all ions, right? But we also had problems where I'd say calculate the concentration of the ammonium ions. You get what I'm saying? Now that would be 2 for 1. If I do all ions, it's 3 for 1. If I did sulfite ions, it'd be 1 to 1. Make sense? So just pay attention what you're calculating the concentration of. There you go, you caught it. Okay, so that's good. So, this step right here of crisscrossing, going from here to here, is only necessary if they give you the name. But if I gave you NH4 parentheses 2 SO4, then you would have to be able to figure out that there are 3 ions. So like Andy said, I know there's 3 ions. So that helps them with this question, but it doesn't help them back up here at dissociation where you're going to have to write these types of equations. Okay. All right, John Vergotz, where are we going to go next? Yes, Jimmy.
So before we do the dissociation, we have to crisscross and then...
If I gave you the name of the compound. If I didn't give you the name, I gave you a formula, then it's already done. Yeah.
So if you give us a formula, it's always going to be done?
It would already have been crisscrossed, yeah.
Okay.
Yeah. Let's not lose sight of what we're trying to accomplish here, John.
I know.
Look at what we're trying to calculate. What is it we're trying to calculate?
The concentration of all the ions.
The concentration of the ions. So what 2 things do we need to know the concentration of the ions?
The moles of all the ions and
The moles of the ions over
liters.
liters. So do we have any of those yet? Don't have either of those? We don't have moles of ions. I agree with you there. Do we have liters of solution?
Yes.
Yes. How much?
Oh, we have 1.5.
So we could write V equals 1.5 liters, right?
Yes.
That's something to get out of the way. And now we know what we got to focus on, right?
No, we don't know the moles yet.
Right. Don't know the moles yet. Peter Frasina's not here. So Liam, John's got us our denominator. We don't have a numerator. How are we going to? Where was our starting point to get to that moles of ions? There's only one other piece of information, and it should be able to be linked to it, right?
So the final answer doesn't have to be over just one?
It's always over 1 liter. Once you divide it out, it'll.
Change that?
Well, you divide it,
Oh.
and that'll reduce it to 1. I don't know about that. Liam, what are moles? Dozen, but a hell of a lot bigger, right? So we want to get to a counting number, right? How do we count atoms? What's one way to count atoms? By how can I count up oranges really fast, or how can I count up elephants really fast? No. How can I count nuts and bolts very fast if I want to count millions and millions of them all at once? Anybody want to help them? Weigh them. So we have a mass, right? We have 132 grams. So let's get rid of what you got there. And let's start out with our 132 grams. And what substance do you have? Yeah. And And how are you going to turn grams into moles? What do you need to know? If I want to count up, say, oranges really fast, what do I have to know about each orange? How much each one weighs. So how are you going to find out how much an NH4SO4 weighs? Now the only problem you got there is you're probably going to run into that in a second with your calculation. So you might want to do that off in a scratch area someplace, like down and away. Because once you start doing this calculation, it's going to stretch over into here is what I'm saying. Okay, once we do this step, we'll turn it into moles. And then we're going to multiply it by what? 3 moles of ions over 1 mole of ammonium sulfate. So we should probably get, let's see, 132 grams. This thing probably weighs, let's see, 14, 28. Okay.